ch4p101. Solve each of the following inequalities. Represent the solutions algebraically and on a number line. Letter A. 2 times the absolute value of the quantity of 3x minus 5 is greater than or equal to 4. I'm going to approach this one a little bit differently than the way I normally do. See if I can maybe show a way that may help some people. I'm going to take whatever I have inside of here and I'm going to replace it. I'm going to actually say let's let u equal the expression 3x minus 5. So I'm literally going to take out this 3x minus 5 and I'm going to replace it right now with u. Now if we look to solve this, remember our goal here is to isolate the absolute value brackets. So 2 times something has got to be greater than or equal to 4. Well, we can divide each side by 2, so we're undoing that, and we get the absolute value of u is greater than or equal to 2. So we're starting out here, we're looking for numbers that are 2 units from 0 or more. So I know that if I was thinking about setting up here, I would say I'd have a -2 and a 2 are both exactly 2 units from 0. So I'd have a closed circle here and a closed circle here. Now this isn't the solution because we're supposed to be finding the values of x. But I'm talking about this value of what is inside of my absolute value brackets. So if I want to be 2 units or more from 0, I would be going out this direction and going out this direction here. So we're going to be more than 2 units from 0 if we're out here, beyond 2, and we'd be more than 2 units if we were out here. Now this is just our value of u. So this would be for our value of u. What we still need to do is we need to figure out what value of x here is going to make it so that our value of u ends up looking like this. So we know though right now that u has to be greater than or equal to 2, because that's what this is. And we know that u has to be less than or equal to -2. So we have or u has to be less than or equal to -2. Well, now that we've established that, let's take our quantity that we had here that we substituted u in for, and let's plug it back in. So we're going to say, instead of u now, we're going to say 3x minus 5, whatever that is. Remember, these are the same thing. These are equal to each other. It has to be greater than or equal to 2. Or our 3x minus 5 has to be less than or equal to -2. Now let's solve it to figure out what values of x will get us to this. So we add our 5 to each side. We're going to have 7. So 3 times some number is greater than or equal to 7. We get x is greater than or equal to 7/3. So any number that we plug in for x, as long as it's greater than or equal to 7/3 here, we'll get a value here that is at least 2 or more. Over on this side, let's take it and let's add 5 to each side. We're going to have a 3 then. And we have 3 times some number is less than or equal to 3. Let's divide each side by 3. And we get x is less than or equal to 1. So any value 1 or less, if we plug it in for x right here, it will make our absolute value here work. So it'll be less than or equal to -2, and that's what we need if we want to have something that's going to work. So how do we represent our actual answer here? We got to look at our values of x. We're not using the u. So as we take it here, what's less, 7/3 or 1? Well, 1 is less than 7/3 because 7/3 is about 2 1/3. So we've got 7/3 here. And each of these inequalities, so if it's going to be greater than or equal to 7/3, we take it, and it's going to go out this way. And if it's less than or equal to 1, it's going to be a closed circle here, and it's going to go out this way, this direction. So our answer there ends up being this. Ooh, almost caught it there. Now, let's check this one on the calculator. Where did my calculator go? Let's bring it back up here. Okay, so as you see here, I have my calculator out. I'm in my y equals menu, and if you look here, we have 2 times the absolute value of 3x minus 5 is greater than or equal to 4. So we want to know when are these outputs going to be greater than or equal to 4. So I took my first expression from the left side of the inequality and I typed it in as one function. And I typed in my right side of my inequality as its own function here. Even though it's just a number, that's okay. Now when we graph it, you'll see here is our 2 times the absolute value of 3x minus 5. And here is our y is equal to 4. So if we're looking for all of the output values for this, so remember all these points are output values, we're looking for the ones that are greater than 4. Well, if this is where we are equal to 4 right here, okay, we're going to say from here up. We're going to say from here out this way. So our x values here, anything greater than whatever this point is going to be a solution. So let's look and see what our solution points are. Let's do second trace. Now let's go to intersect, number 5. Let's mark each of our functions here. And so we know that when y is 4, when our output is 4, our input is 1. Well, didn't we say that there? X has to be less than or equal to 1. So from 1 back this way is a solution. And then if we go from this point on this direction, notice there that our blue line is above the red line, so we are greater than. Well, I bet you that's probably going to end up being 7/3 or 2 1/3, right? Let's double check. Second trace, number 5. Remember, we got to move it a little bit closer to that intersection point using the right and left arrows. So enter, enter, enter. We get 2.3 repeating, which is the same thing as 2 1/3 or 7/3. So from 2 1/3 here on, our blue function here, which is our absolute value function, has outputs that are greater than 4. So we know we're right there. Let's look at letter B now. We've got 1/3 times the quantity of 3x minus 6 to the 3rd power plus 4 is less than 13. All right, so let's do this. If we're going to have to break our x out of here, we got to get rid of everything on the outside first. So some people take it and they get rid of the 1/3 by multiplying by 3, but if you do that, make sure you multiply this term by 3 and this term by 3 and then the other side of the equation. I don't do it that way. I undo my order of operations backwards, so I subtract 4. As long as you're following your rules, your algebraic properties of equality, you can do whatever you want, as long as you're doing them correctly. So we've got 1/3 times the quantity of 3x minus 6 cubed is less than 9. Well, to get rid of the 1/3, we can divide by the 1/3, or we can multiply this term by a 3 and multiply this one by 3. 3 times 1/3 is 1, so 1 times all this is going to keep it the same. So we've got the quantity of 3x minus 6 cubed, and that's going to be less than 27. Oh, what a nice number. How do you undo something that's cubed? Well, you're going to have to do the inverse operation, which is taking the cube root. Take the cube root of the left side, take the cube root of the right side. These will cancel each other out. And you're left with 3x minus 6 is going to be less than what number times itself is going to be, times itself 3 times is going to be 27. Well, remember, this is like saying the cube root of 3 cubed, because 3 cubed is 27. So those will cancel each other out, and we get that that is less than 3. Now we just got to finish solving it for x here. So let's subtract 6. I'm sorry, add 6 to each side. You get 3x is less than 9. 3 times what is 9? That would be 3. So we know that x has to be less than 3. If we want to represent this on a number line, in this case, we just have one inequality. So we've got 3. Always make sure, though, you include some other value on your number line there to make sure that your numbers aren't set up backwards. And is 3 going to be a solution? No, it's not, because it can't equal. So we want to make an open circle, and we want to go to the left. How do we check it? Let's take a value that's less than 3 and plug it in. I like to use, let's go ahead and use 2. I like to use 0 a lot, but let's use 2 here. So let's check it. So, actually I might need to scoot it up there because my memory is not great. So 1/3. Let's plug in 2. We're going to say, we're going to put in 2 into it. 1/3 times the quantity of 3 times 2 minus 6 cubed plus 4 is less than 13. 3 times 2 is 6. 6 minus 6 is 0. Awesome. How convenient. Zero cubed is 0, times 1/3 is 0, plus 4 is 4. Is 4 less than 13? Yes, it is, so we know that we are correct. So our answer here is going to be x is less than 3. This is what our number line should look like. And if we want to check it on our calculator, we can do that. If I can find my calculator again. There it is. Let's go back in. Let's do the exact same thing we did with the other one here. So let's clear out our functions. And let's do, oops, sorry, wrong button. All right, alpha, y equals, let's bring up that fraction menu. Let's do 1/3. And we have times the quantity of 3x minus 6. Close it, raise it to the 3rd power, plus 4. And then remember our second function is the right side of our inequality. So we're looking, since this is less than 13, we're looking for all of our points on this graph that we've just typed in here that have outputs less than 13. So it's got to be under that line that we get for 13. Let's check it out. Now we'll probably have to adjust our dimensions. Let's see. There's our cubic function. And there's our line where y equals 13. That means everything below this line is where we are going to hold true, and this is going to go on and on forever, right? So it's going to the left. So our point right here should be 3. Let's check it out. Second trace, do our intersect function. So our first curve, we're at our second curve. Our intersection is 3. So x is 3 and y is 13. So we know that everything less than 3 for our x values is going to give us points down here. So we are correct. So remember, that's just another way to solve it or to check it there. Hopefully this helped you out there. This is problem 4-101. If you have questions, make sure you ask your teacher or you go visit somebody to get math help. This is Mr. Boyd, signing off.